Today we are going to talk about development of calculus. What is calculus? Basically, calculus studies the rate of change of a quantity over time. It could be divided into two categories. The first one is differential calculus. It calculates the rate of change of a quantity, such as how the position of an object changes compared to the time. The second category is integral calculus. We use them to accumulate or sum up infinitely small quantities. It's often used to calculate area under curves. To start with, we must talk about a very important person, Isaac Newton. He born in 1642 and died in 1727. He is an English mathematician, physicist, astronomer, theologian, and author. He is one of the most influential scientists of all the time, and he built the foundation of modern calculus. When Newton was trying to describe the speed of a falling object, he found that speed increases every second, but there was no existing mathematical explanation for it. This issue had not yet been explored, so Newton began to work on this. He explained how the planets moved using calculus. Newton also developed his own method. In this case, when we are trying to find a point fx equals to 0 on the graph, he first set up a point x0. He drew a tangent line on fx at the point x0, which crosses x1 on the x-axis. He then drew a tangent line x1 and crosses x2. He repeats this process several times, and he can finally reach the point where fx equals to 0. Another very important person is Gottfried Wilhelm Leibniz. He was born in 1646 and died in 1716. He conceived the ideas of differential and integral calculus, and his notation, dy dx, has been favored as the conventional expression of calculus until now. Both Newton and Leibniz contributed a lot for the modern calculus, but they still have a little bit of difference. For example, Newton used notations f prime and y prime, while Leibniz used dx and dy. Leibniz just developed a similar system of calculus slightly later than Newton, but he published his work earlier. He published his first book in 1684, but Newton published his work in 1693. So the Royal Society in London decided to give credit to Newton for the first discovery of calculus, and Leibniz for the first publication. However, both of the area formula and the power series for the sign have been known for hundreds of years in Egypt. Ibn al-Haytham, an Arab mathematician, developed a method that could be used to determine the sum for any integral power, and used it to find the volume of a paraboid. Another important mathematician for the development of calculus is Archimedes. He used infinitesimals similar to modern integral calculus. Through proof by contradiction, you could specify the limits of the answer. It is also called the method of exhaustion. He used it to approximate the value of pi. In the 3rd century BC, Archimedes proved that the region enclosed by a parabola and a line is 4/3 of a certain inscribed triangle. With the method of exhaustion, he dissected the area into infinitely many triangles and computed the sum of them. Now, we have a formula to calculate the area between two curves.